Assalamu alaikum. My name is Ibrahim and this is my demo for machine learning 2 project. My project makes use of my thesis dataset, which comprises of clinical and intraoperative data of cardiac patients. The objective is to predict the mortality based on those variables. The data is highly unbalanced, with majority level being 0, which signifies not dead or alive. So first of all, installing all the libraries, reading the dataset and checking the d-types of each column. Later, I excluded those columns that I believe are not useful or has any impact on the dependent variable. Also, all the date-related variables were excluded after converting them into number of days. The first pre-processing step is to check for missing values, which is done by this block of code. As you can see, there are many variables that have missing values. So most of the missing values were filled by 0 by analyzing the data in more detail. Few variables like BMI and hypertension were filled by using their related variables like weight and height for BMI and BP systolic for hypertension. All other variables where no relation or intuition could help, I interpolated those missing values. This is the final data set, as you can see, on which the analysis was done. The methodology of this project is as follows. Firstly, I created 3 baseline models using XGBoost, logistic regression, and a random forest by using k-fold cross validation technique. All features of the data were used, nothing was excluded except from the ones that were excluded in the pre-processing step. Apart from that, all the other variables were used. This was done to check if my choice of machine learning model is actually correct or not. As you can see from the ROC of these 3 models, all of them performed quite well with ROC of 0.954 for logistic regression and 0.997 for XGB, 0.99 for XGB and random forest. Then I created single standalone models trained on training data and tested on testing data. Again, all features of the data were used and the data was kept unbalanced. XGBoost performed the best in terms of ROC of 0.97, followed closely by random forest with ROC of 0.95. However, the precision of classification, which is in my opinion is a more significant metric than ROC, is best for random forest with precision of 0.97 and XGB had only precision of 0.93. Later on, the standalone models that I created was on balanced data. So after checking the model accuracy on imbalanced data, I balanced my data and oversampled the observations, having one as class label. Again, I trained XGB, logistic regression, and random forest classifiers. Again, XGB performed the best in terms of ROC, which came out at about 0.99, followed again closely by random forest with ROC of 0.987. However, this time once again random forest managed to beat the XGB classifier in terms of precision and managed to get the outstanding precision of 0.99 on the test data. The next thing in the project is to use these 3 classifiers, XGB, random forest, and logistic regression, and assess their accuracy when different feature selection techniques like random forest, XGB, L1 means lasso, L2 or bridge, and PCA are applied. These are just the classifier functions. As you can see here, these are nothing but the classifier functions pertaining to each feature selection method. So firstly, feature selection is done, PCA feature selection is done on imbalanced data. The PCA was trained for different number of feature values and the accuracy was assessed. As seen from the results, the ROC kept on increasing for all 3 classifiers as the number of features increased. The best ROC of 0.81 was achieved with XGB classifier and PCA as a feature selection technique. The best ROC for random forest classifier and PCA feature selection technique was 0.83. The best performing among all was logistic regression, which managed to get an ROC of 0.85 as the highest one on PCA feature selection technique. I tried using LDA feature selection technique as well, but it prompted an error because my scatter matrix came out to be a singular matrix with a determinant of 0, hence LDA couldn't be applied on this dataset. Later on, same as PCA, L1 regression is used to assess the classifier's accuracy on different numbers of features, with L1 as feature selection technique and XGB as the classifier. The best ROC was 0.996 with 47 number of features. With random forest as the classifier, the best ROC was 0.995, and with logistic regression, the highest ROC was 0.989. Later on, a similar analysis was done on L2 as say similar to L1, XGB, and random forest. For each feature selection technique, the results were assessed with on three different classification models. In fact, the accuracy or ROC for all feature selection techniques were quite comparable, and it does not differ a lot. The next thing that I did was that I applied the same methodology as above, with the only difference that now the data was balanced. Again, PCA, L1, L2, XGB, and random forest feature selection techniques were applied, and the models were created and tested. The overall results got better when the data became balanced. Next, I created a few naive Bayes classification models. The first one was Gaussian naive Bayes that resulted in the ROC of 0.90. Then the multinomial naive Bayes that resulted in the ROC of 0.84. Lastly, I built a Bernoulli naive Bayes that gave out the ROC of 0.93. The next part of my ML2 project is to analyze and train the same data using MCMC methods. I was actually hesitant to use my Jupyter environment for PyMC3 because it prompted me to update my pandas and other related libraries, which I was